Hello and welcome to my class. I'm Grolin Annalisi from ThinkMo Education. I'm currently a Cisco Technology lecturer. If you like my video, welcome to my study group. Or contact my teaching assistant. WhatsApp account is +6 583444290. Today's topic is ACL, NAT, and SDN. We talked about some basic concepts of ACL in the last class. Actually, ACL is based on the current network status. When the communication has been completed, then go to do some corresponding control in a targeted manner. Then control access between some data. So let's talk about the experimental part of ACL now. Let's practice. Look at this picture. This is the experimental environment. The requirement is simple. PC1 cannot ping PC2. But today, I'm going to teach you some configuration commands that we haven't learned before. Everyone will find there is a PC1 on the left. It is on the 10.0 network segment. There is a PC2 on the right. It is on the 20.0 network segment. In short, both of them are across network segments. There must be a gateway in between. So here the gateway is introduced. Since there are two devices in the middle, definitely the device we're going to configure accordingly. First, I need to make sure the network can reach the device on the right. That is to say, these two devices need to run the corresponding routing protocol. Then let's configure them. Today our configuration is done on the device R1. That is, I hope that when PC1 goes to ping PC2 again, traffic sent. But it can't reach PC2. This is what we call access control. So we need to be on the left interface of the R1 device. Hook up the ACL. That is, configure the corresponding ACL policy on it. Then intercept the data under the interface. When I send data through this interface, after being matched by the interface, then we intercept the message that PC1 wants to ping PC2. It will not be forwarded by the router. In this case it will not be able to ping. This is what we want to achieve. Then let's see how to achieve. Before we realize the requirements, definitely have to do some basic configuration of them. We need to configure some basic addresses for PC1 and PC2. First is PC1. We directly configure the IP address 192.168.10.1. 24-bit mask. Gateway is 192.168.10.254. This is PC1. PC2 is 192.168.20.1. 24-bit mask. Gateway is 192.168.20.254. OK. After configuration, we are going to run the corresponding routing protocol on the router. It starts slowly. We are still running OSPF. Although you will learn EIGRP in Cisco, including you will continue to learn in the future. But to be honest, it's really not used much in the network now. There are many application scenarios of EIGRP before, but not anymore in recent years. Or equipment. So let's see. We still run OSPF. First do some basic configuration. Let's name it first. A lot of content today revolves around experiments. By the way, everyone will also review the previous experiments. This is R1. The right device is the same. This is R2. Remember how to run OSPF? Before running, we have to configure the address for it first. E01 interface. This is interconnected with PC1. Its address is 192.168.10.254. It has to be the gateway of PC1. 24-bit mask. Then we go to the E00 interface. The address is 12.1.1.1. Then go to R2. R2 is the same. 00 interface. 12.1.1.2. Then the 01 interface. 192.168.20.254. OK. After we finish the basic configuration, start configuring OSPF. First configure a process ID. Suppose the process ID is 100. Router OSPF 100. We will not enter the router ID here today. We just declared. I teach you a new way of declaring. This way of declaring that we haven't talked about it before. But you can do this as an experiment. Definitely don't use this at work. 0.0.0.0. 0.0.0.0. Area is also 0. This is how we declared before. For example, there is a 192.168.10.1 on the left. Then I declare 10.0. Then R1 and R2 are interconnected here. I declare 12 network segments. Neighbors between them. After declaring the directly connected segment, pass routing information on both sides. Then we declare that 4 zeros are the full declaration. Full declaration. Declare all the interfaces on the current device. Look. All are 0. Mask is also 0. Full declaration. Once you enter this command, both interfaces of R1 are fully integrated into OSPF. Here is a simplified command. Sometimes you want to do some low-level configuration through OSPF. Then you can go for a full announcement. But if other experiments you do in the future will be related to the details in OSPF. For example, there are a lot of routing entries. Then you probably want OSPF to be more granular. Don't do it this way. But this can be used for your daily experiments. OK. Router OSPF 100. Then declare. Full declaration. When we declare done, we'll just wait here at R1 for a while. Let's check the routing table. It will be slightly slower. OK. It learned the route of PC2. We have to wait a while. So OSPF does have a bit of waiting time. This is learned in OSPF. The route of R1 to network segment 20 is this segment. It has learned. This is the OSPF we talked about earlier. We can then let PC1 go to ping PC2. First test their communication. Ping 192.168.20.1. It works now. PC1 is 10.1. PC2 is 20.1. OSPF is running in the middle. The two PCs are connected. Then I now hope that PC1 cannot ping PC2. Before we configure, we're going to review the ACL first. First of all, it must be configured according to actual needs. Now this is the need. Actually, we can do configuration anywhere. You can also try it after class. It is also okay to do it on the left interface of this device. But because the source IP of the layer 3 IP address will not change, including the peer service you visit will not change, you can do the same under this interface. Then we will configure it under the left interface of R1 today. I don't want it to ping right now. If I intercept this data, I mentioned ping. What can you think of? This ping we send must be a message. Then when I go to ping, I am sending an echo message. It is an ICMP message. It is divided into two. One is request. One is reply. Echo is request. Echo reply is reply. Actually, You can kill the request or you can kill the reply. But we usually kill the request. Because it's more crisp. Don't let this message pass. So we configure on R1. Now we have finished the basic configuration of R1. So now I'm going to enter the ACL on R1. We haven't talked about ACL configuration before. ACL is called access list. Let's enter a question mark to see. Here, as we said before, 1 is standard ACL. It is from 1 to 99. 1 is extended ACL. Is 100 to 199. Actually, there are relatively few scenarios where basic ACLs are used. As a basic ACL matches the source IP. For example, if you are now denying the source IP of a data. So now this source IP can't go anywhere. As long as this interface deny it. It cannot access all network segments and services in the rear. So, this is equivalent to directly limiting the overall communication capability of this address. Such lethality is too strong. So actually, we don't use a lot of basic ACLs. We actually use more advanced ACLs in our lives.